Number 6, Randall hit a golf ball with initial velocity of 150 feet per second at an angle of 29 degrees with the ground. Find the distance the golf ball travels. So here's Randall out here, and he's golfing, and he happens to hit this ball, and it comes off, and it's going to travel some long distance before it comes down and hits the ground. So that's kind of what happens here. Now, it says the ball leaves the ground at 29 degrees. Now, when it reset my graph, it doesn't really make it 29 degrees anymore, but 29 degrees would be from the ground here. That would be 29 degrees. And it says it leaves at 150 feet per second. Now, that is a vector because it takes off on a straight line, but what happens is gravity pulls it down. So 150 feet per second. Now it says find the distance ball travels. What we're going to do is we're going to use a projectile motion formula from the formula chart. If I go to the formula chart and I scroll down here on the front page, you'll see these two equations. These are what I'm going to use. So I'll have x equals initial velocity times cosine times time, and then the y will be -1/2 gravity times squared plus initial velocity times sine of t, and then also we're going to add our initial height. Gravity is either 32 feet per second squared or 9.8 meters per second squared. This problem, it said 150 feet per second is what the golf ball took off at, so we're going to use the number 32 for gravity. So I'm going to come back over here, and I'll write out the equations. X equals, if you remember, it was initial velocity times cosine theta times time. The y equation was -1/2 g for gravity times squared plus v0 sine theta times time plus the initial height. And we said that g in this problem is going to equal 32 feet per second squared. That's our number we're going to use. So when I plug in my equations, what I'm actually going to type in is x is equal to the initial velocity, which is 150 cosine of 29 degrees times time, and the y equation is going to be -1/2. So the gravity, I'm going to put 32 times squared plus the initial velocity is 150 times sine of 29 degrees times time plus the initial height. What's our initial height? For a golf ball, you hit it from the ground, so it's +0, or you could just simply erase it. You don't even need that if it's 0. So let's go to our graph, see what we come up with. We go to new document here to clear that out. And so graph, and it's a parametric equation. So my equation was 150, oops, got the parentheses. So I'm going to hit parentheses here. 150 cosine of 29 degrees. Put the degree symbol in there. And that t, the number one mistake people make is they forget to put the t in the outside of the parentheses. And for the y, it was -1/2 32 t squared plus parentheses 150 sine of t, not of t, I'm sorry, of 29 degrees again. And put the t on the outside, and it was +0, or you can just leave it. I don't know how long it's going to be in the air, but I know it's not going to have negative time. So I'll just leave that as is. I'm going to go menu for A, which will zoom fit us. We can see that 6.28 seconds is way more than enough time. Now, what are we supposed to find? It says find the distance the ball travels. So we want to know when it hits the ground here. So we'll go menu, trace, and I'm going to use graph trace. And as I trace it, I want to see when it hits the ground. So here, this is the x value. This is the y value. This is the time. Right now, it's 3.25 feet off the ground. And now it's -4.04. So it's somewhere between here. It's between 590 and 603. Well, that's not very close. Let's see if we can get closer. Here's what you do. You hit menu, you go to trace, and hit trace step. Now, normally it counts, well, the trace step, the automatic, means it's counting by 1/10 of a second. We're going to change this to 1,000th of a second. I'm going to do 0.001. This will get us really close. So right now, I'm at a negative height, so I need to go back. I'm going to look for when it hits 0. I want to get as close as I can. So I'm going to keep hitting left here to go backwards in time. And I'm trying to find out what happens when it hits 0. Now, as we get closer, we can see this is about just barely off the ground. That's not even 1 inch off the ground. It's at 596 feet. So that's going to be my answer. I'm going to say that my answer is 596 feet for the golf ball. That's how far it travels, and that happens, again, when you have 596, when it was 0.007 feet off the ground, and that time value with it was, if we're interested, 4.54 seconds. That's how long it was in the air, and it traveled this far, and it's in feet.